Okay, next we're going to look at simplifying radical expressions with odd exponents. Okay, a variable with an odd exponent is always the product of a perfect square and the variable. So I'll show you that with taking a look at x to the third. I can write x to the third as x squared times x to the first. I can write, let me show you some other examples. I can write x to the fifth as x to the fourth times x to the first. We said every variable with an even exponent is a perfect square. So when you just add these exponents, you pretty much just subtract 1 from there. That gives you the perfect square. Okay, and then the variable to the first power. So now we've already learned that a radical is not simplified if the radicand's the number under the square root, has a factor that's a perfect square. Since x to the third has a factor that's a perfect square, we need to simplify this. So you could think of this as writing this as the square root of x to the second times the square root of x to the first. Okay, the square root of x to the second is x. Okay, and now I still have a square root of x to the first left. Since this is an exponent of 1, it cannot be simplified any further. Now there's a shortcut with that. You don't always have to rewrite it. Okay, so to simplify a radical expression with an odd exponent, we're still going to just divide the exponent by 2 and write the variable to that power outside the radical and write the variable to the power of the remainder under the radical. Now, the remainder is always going to be 1 here in Algebra 1, always 1. Until Algebra 2, if there's a remainder, it will always be 1. When you start going into Algebra 2, you're going to have to simplify cube roots, fourth roots, fifth roots, and then you can get different remainders. But when you're talking about square roots, it's always going to be 1, because when you have a perfect square, the other factor is always going to be the variable to the first power, as you can see up here. So let's go through 2 quick examples. So we've got x to the 9th. So if I wanted to break that down, I could say that's the square root of x to the 8th times the square root of x to the 1st. Then using what I did above, I can taking the square root, so I can do 8 divided by 2 is 4, and x to the first. So the shortcut is just divide this by 2. 9 divided by 2 is 4, and there's a remainder of 1. Number 2, let's do the square root of x to the 17th. If I wanted to break this down, that would be the square root of x to the 16th times x to the first. Because then I could say 16 divided by 2 is 8, and that remains under. So with the shortcut, once again, you could do 17 divided by 2, which is 8, and it's got a remainder of 1.